Over 130 million years ago, during the early Cretaceous period, a new type of plant began to diverge from the gymnosperms of the time. These plants, now known as angiosperms, were the first flowering plants to grow on the planet. In present day, there are over 300,000 species of angiosperms found around the world. One of these angiosperms, Symphyotrichum novae-angliae, commonly referred to as New England Aster, can be found within our own state of Connecticut. With thick, mostly woody stems arising out of the ground, and simple leaves covering the majority of the stalk, the plant branches out to bloom beautiful clusters of purple flowers. The outer portion is composed of 40 to 100 purple ray florets, while the center contains 50 to 110 yellow disc florets. This flower structure of ray and disc florets is commonplace for any flower of the Asteraceae family. Some other common flowering plants with this arrangement are sunflowers and daisies. New England Aster is native not only to Connecticut, but most of the East Coast and Midwestern regions of the North American continent. Despite how widespread this flower is across the country, it's not entirely safe from the presence of modern-day human infrastructure. Their conservation status may be held as secure by the Nature Reserve conservation status. However, much of its natural habitat has been disturbed by human development along the East Coast regions, and much of this habitat is no longer considered to be remnant. The reason that S. novae-angliae can withstand such disturbances in land is due to its flexibility in environmental conditions. Though this flower may prefer to grow in wetlands, it has been found surviving in dry, sandy conditions around the Niagara region of southern Ontario. The deforestation of lands may also benefit S. novae-angliae, as it is found in open areas like marshes and meadows, and only along the edges of forests. The only other preference this plant has is for soil pH, growing best in soils between a pH of 5 and 7. New England Aster's interactions with the surrounding ecology have also been seen as beneficial to the insects, birds, and other pollinators. These animals are able to use the pollen and nectar from within the flowers as a food source. During the later months of the year, around autumn and winter, the seeds of S. novae-angliae become an essential source of food for songbirds. By carrying and crossing pollen from flower to flower, these pollinators are what allow the plant to overcome the hurdle that is cross-pollination. Once cross-pollination occurs, S. novae-angliae can disperse its seeds so that more flowers can bloom. So that new plants don't just cluster around nearby soil, S. novae-angliae uses the power of wind to carry its seeds far away. And by forming tufts of hair at the end of each seed, the flower changes into a puffball shape that can more easily catch this air and pull away the ready seedlings. When the seeds finally settle to the ground, with preferable conditions, and if they don't get picked up by any songbirds, they can grow into new flowers and start the cycle of S. novae-angliae anew.